Okay, hi. So these are about six ACT problems. So let's get to it. This one says a square is circumscribed about a circle of 7-foot radius, as shown below. Okay, so if the radius is 7 feet, then the diameter is 14 feet, right? So if that diameter is 14 feet, then it's 14 feet in this direction, in that direction, in this direction. So that would mean that there can be a parallel line that runs from here to here, just like this one right here. Alright, they're parallel to each other, but they're both 14 feet. And because that's a square, it's going to be 14 times 14. So 14 times 14. Yeah. So we look at it, 14, there's a square. Answer is K. Alright. 2 workers were hired to begin work at the same time. Worker A's contract called for the starting salary of $20,000 with an increase of $800 after each year of employment. So when they set up problems like this, you're usually, like, systems of equations is something that they like to use. I don't know why, but they like to test your knowledge on systems of equations. And a lot of the time, it has to do with 2 variables. So right off the bat, you want to start counting how many variables you have and also like what they are. So I already know that year is going to be one of them. So I'm going to say x equals year. Okay, so worker B's contract called for a starting salary of $15,200 with an increase of $2,000 after each year of employment. Okay, so we have both of their starting salaries, and those are constant. So A has a starting salary, B has a starting salary. A's is $20,000, B's is $15,200. Now both of them have this like yearly increase, and that is when the variable plays in. So we're going to use this x, and we're going to put in 800x for this guy, and then what is this guy? 2000x for that guy. So the question is not what is the number of years it's going to take. The question is what is the equation. So in order to solve this, you would just set them equal to each other. So we're going to see what that looks like. Okay. So that one looks like it. Right off the bat, that looks like it. Yep. So it's A. Alright. So next one is, one of the following is an equation of the linear relation shown in the standard xy coordinate plane below. Which equation is it? Okay, so for these, we have y equals mx plus b, where b is the y-intercept. So y-intercept is where does it cross y? Here, 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 here. So b is the y-intercept. M is slope, rise over run. And then x and y are just the x and y value. So, first thing we can observe is the y-intercept. It's 5, so it's positive 5. So there it is, positive 5. It's E. But let's say we didn't know that. So let's say we could eliminate this one, and this one. Okay, then you would look at rise over run, right? Oh, it's 2 for both of them, yeah. Really the only way that you would know it is by just knowing that that's the y-intercept. So it's literally E. That's the only answer, only way you can really find it. Okay. A ramp for loading trucks is 13 feet long and covers 12 feet along the level ground. How many feet high is the highest point? So we have a right triangle, which is nice. I'm gonna make it bigger. The hypotenuse is 13, and we're looking for x. We're looking for the highest point on the ramp, which is right here. We're looking for the height. Okay, so Pythagorean theorem, a squared plus b squared equals c squared. I labeled this wrong. It's actually this. So then c squared is the hypotenuse. So c squared is 13 squared. Why is it not 13? Because c is 13. This is a, this is b, and this is c. The value is 13 squared. It's kind of like a ratio rather than it's a straight up equation, but it's decoded. It's encrypted a little bit into this weird thing. So it's actually 13 squared. So don't forget that on the test. It's not 13. It's 13 squared. And then you have 12 squared plus some unknown value, which we call to b. So this is 169, 144, b squared. Okay, so I found what all of these were. Now I just do algebra. Okay, so I find that b squared equals 25. I find the square root of both sides. B equals 5. So the height is 5. So it's J. Okay. So we have this one. Let's see. Let's do pink. Okay. So what's the area? They give us this side, they give us this side. We're missing this. Okay. My favorite technique is to just break it up. So you could break it up in 2 ways. You could break it up like that, or you could break it up like this. I'm gonna break it up like this. So this is 5. Now, if this is 25, and this is 15, and this is 25, right? Then this has to be 10. So this is 10. 5 times 10 is 50. Alright, great. Now, if this is 15, and that's 15, then that's a perfect square. I don't know, 15 squared? Okay, it's 225. So then you add them. It's H. Finally, Hi has a $100 available, to buy USB drives to back up data for his business computers. Each USB drive has a price of $8, and Hi will pay a sales tax of 7% on the total price of the USB drives. What is the maximum number of USB drives Hi can buy? Okay, so Hi has $100. Each drive is $8. Tax is 7%. So my favorite way to do it is to just find the tax per unit. So something that's easy for me to visualize is, okay, so you have $1, right? So a dollar is 100 coins. So imagine that this is like 100 coins, whatever. If you have 7% of those 100 coins, then that's 7 cents, okay? So if one of these little flash drives, and let me draw a flash drive. Okay. If one of these little flash drives costs $8, and for $1, 7 cents is the tax, then 7 times 8 is 56 cents. Therefore, each one of these has 56 cents of tax. Alright, great to know. That means each one cost $8.56. Now, the real question is, how many times does $8.56 fit into 100? So, let's see, $8.56 fits into 100 how many times? So, they start giving us the option at 11, and then it just keeps going. So, we're basically going to do 8.56 times 11, 8.56 times 12, and so forth, until we find the number that lets us know the most USBs he can buy. This is 94.16. Alright, and then this is 102.72. So already he can only buy 11. So the answer is A, 11. So yeah, I hope that helped.